Okay, first thing I want to bring to your attention, logarithmic equations. You want to have these properties in mind when you're doing logarithmic equations. And that's on a sheet I've given you in the past, so I'm not going to print it off again. But if two logarithms are being added together, you multiply the arguments. If two logarithms are being subtracted, you divide the logarithms. If there's a constant in front of a logarithm, that becomes the power of the argument. That should be dealt with first before you do these two steps. You want log plus log minus log before you worry about multiplying and dividing. Any numbers in front of logs must become powers first if you're going to do that, right? And finally, if log of x equals log of y, then x equals y. You have the ability then to get rid of the logarithms and make it just an algebraic problem at that point. So that's our overall goal. I want to get to this point using these techniques. Once I get to this point, argument 1 equals argument 2. Now it's not a logarithm problem anymore, it's just an algebra problem. Solve that however you would solve the algebra problem. So, example 1. Oh, and one extra thing, and this happened yesterday, if log equals number, change it to exponential form. So that happens often also. So sometimes log equals log, sometimes log equals number. Depending on which one you get, you have to deal with it. So in this case, example 5, log of 2x minus log of x minus 3 equals 1. All right, the logs are base 10, understood, right? Yeah. If everything's log, it doesn't matter what the base is, as long as it's the same, which it will be. Yeah. But if log equals a number, or if some log stuff equals a number, you do have to have that base that you want to look at it. So I would write a base 10 personally. Looking at the logarithmic expressions, I've got just log. I've got just log. There's no numbers out in front of the logarithms, so I don't have to worry about any power. So I can go directly to the fact they're being subtracted. That changes it to log base 10 of the first argument, which is 2x, divided by the second argument, x minus 3 equals 1. So again, using those laws of logarithms to transform that left side into just a single logarithmic expression. Once you get to a single log, log of something equals number. Again, if it equals number, we're going to use exponential expression. So this base raised to that power, which is 10 to the first, is equal to the argument 2x over x minus 3. And that creates for us just an algebraic problem. And the fact that it's just a single thing equals a fraction is probably easier to create a proportional to it. So 10 over 1 equals 2x over x minus 3. Keep in mind x minus 3 is a binomial, so when we cross multiply that has to be accounted for. So 1 times 2x is 2x on the left. 10 times x minus 3 is going to be 10x minus 30. So again, 10 times x and 10 times negative 3. All right. Probably moving 10x to the left is easy enough, so if I move the 10x over, it becomes negative 10x. So that gives me 2 minus 10 is negative 8x on the left side, negative 30 is left on the right-hand side. Divide both sides by negative 8. The correct answer is 15 over 4. 3.75 is fine. I'm fine with decimal approximations in this area. If you want the exact right answer, 15/4. So that's also the exact decimal answer since it happens to terminate. All right, and again, the verification process for a logarithmic equation, we cannot have negative or zero arguments. So if we go back to the original problem, here's argument 1, here's argument 2. I don't care what it equals as long as it's not negative. So don't get hung up on getting the exact value, just know that it's positive. So 2 times 3.75 is going to be positive, right? Two positives. 3.75 minus 3 is bigger than 0, so again, it equals 0.75. Sometimes they're not as easily figured out, but just know that positive is what you care about. You don't care what the actual number value is there. So do enough of it, just a self-check there to figure that out. So my answer 3.75 is alive and well. It's perfect. Okay. If, let's say we got 1 as an answer, 2 times 1 is 2, but 1 minus 3 is negative 2, you'd have to throw it out, and then you'd empty set if that's the only answer. So if that happens, that's how you handle it. It will happen occasionally. Sometimes the answer you get will not work, and in which case you have to throw it out. If you get 4 or 5 answers and 3 of them don't work, the other ones do. But if you get 1 answer, it doesn't work, it's empty set all the time.